Welcome back on the class of design of concrete structure. So I hope you all are safe and doing well. So in the previous discussion we have seen that how to design a two-way slab. So the condition of two-way slab when our span, longer span to the shorter span is less than equal to 2. So in the design of two-way slab I have discussed about two methods. One is Rankine-Grashof theory and another today I will going to discuss, that is Marcus method. So in the Rankine-Grashof theory we have seen that how to compute the load. So load is distributed in two directions, that is in x direction and y direction. So load in x direction is computed by R4 by 1 plus R4 into W, where R is the span ratio, longer span to the shorter span ratio, and similarly load in y direction is 1 by 1 plus R4 into y, and with the help of that we have computed the bending moment in x and y direction, that is mx is equal to wx lx square by 8 and my is equal to wy into ly square by 8. And after that same procedure to compute the depth and check for the shear and development length. So in Marcus method, today I will going to discuss Marcus method. So in Marcus method there is a load in x and y direction will be same as the Rankine-Grashof, because this is the modification over the Rankine-Grashof theory, but a reduction coefficient given by the Marcus, so we have to multiply this reduction coefficient in both the loads. After that I will discuss how to design the shear. So Marcus has given the expression to compute the shear force in x and y direction, and after that I will discuss very important method to compute the design of restrained slab, that is IS code method. So let me explain what is Marcus method. So as I told you earlier that Marcus method is a modification over Rankine-Grashof theory. So this method is a modification over Rankine-Grashof theory. A reduction coefficient is multiplied to Rankine formula. So what is the reduction coefficient? So reduction coefficient suggested by Marcus is C is equal to 1 minus 5 by 6 R square divided by 1 plus R4. So this is the reduction coefficient suggested by Marcus, where R is the span ratio Ly by Lx. So moment formula according to Marcus, mx is equal to c into wx into lx square by 8, where wx is same as suggested by the Rankine. So wx is R4 by 1 plus R4 into W, and similarly moment in y direction is equal to C into Wy into Ly square by 8. Where Wy is equal to 1 by 1 plus R4 into W. Similarly, check for the shear. So shear force So this is the distribution of shear force. Shear force, factored shear force in x direction and factored shear force in y direction. So shear force along shorter edge, that is Lx. So shear force, factored shear force suggested by factored load into Lx by 3. So this is the shear force in x direction. Similarly, shear force along longer edge, so factored shear force in y direction is factored load into Lx into r by r plus 2, where r is the span ratio, longer span to the shorter span, and Lx is the length of shorter edge, and the remaining procedure is same, only shear force. So in the previous discussion we have computed the shear force is equal to WL by 2 for a simply supported slab, and for the continuous slab, in the previous discussion I told you that it can be computed using IS codal provision, and code suggested the shear force coefficient at the support and at the critical section, and the critical section is at a distance of small d from the support. So there is one problem related to the Marcus method. Design a slab of clear span 4 meter by 5.8 meter size and simply supported on all 4 sides with corner in held down position, and we have to use Marcus method. Live load is given 6 kN per meter square, floor finishing is given 2 kN per meter square, and we have to use M30 grade of concrete and Fe415 steel. So as we know that Marcus method is applicable for two-way slab. So for two-way slab, span by D ratio for Fe415 is 28. So overall depth or thickness of the slab can be computed span by 28. So span is shorter span 4000 divided by 28. So it is coming 142.86 mm. So provide capital D is equal to 160 mm. Hence small depth is equal to 160 minus 30. So 130 mm is the effective depth, as I provided 30 mm is the effective cover. Similarly, load can be computed. So wind load, live load is 6 into 1 into 1, so 6 kilonewton per. Similarly, floor finishing, 2 kilonewton per meter square, and dead load is overall depth 0.16 into 1 into 1 into 25, so it is 4 kilonewton per. So total load is equal to 12 kilonewton per meter square. Similarly, effective span can be computed. So effective span Lex is equal to Lx naught plus D plus W, whichever is less. So effective span in x direction is 4 plus 0.13, so it is 4.13, and effective span in y direction is 5.8 plus 0.13, so it is 5.93 meter. So once we can check by, sorry, so it is 5.93 divided by 4.13, so it is coming 1.44 less than 2, so it is a two-way slab. Moment can be computed, moment as per Marcus method. So bending moment in x direction is, coefficient is 1 minus 5 by 6 r square. So 1 plus 1.44 square divided by 1 plus r4, 1.44 to the power 4 into wx. Wx is r4 divided by 1 plus r4 into load. So load is 12 into Lx square, 4.13 square divided by 8. So it is 0.674 into 0.8113 into 12 into 4.13 divided by 8. So load is coming 40 kilonewton per meter. Similarly, moment in y direction can be computed. So same bending moment coefficient into Wy into Ly square by 8. So 0.674 into 1 by 1 plus 1.44 to the power 4 into 12 into 5.93 square divided by 8. So it is coming 6.75 kilonewton meter. So dear student, till now I have discussed what is Marcus method. So Marcus method is the modification over the Rankine-Grashof theory. Everything is same except the reduction coefficient suggested by the Marcus, that is 1 minus 5 by 6 r square by 1 plus r4. So this reduction coefficient we have to multiply it in the bending moment for the computation of bending moment in x and y direction. Once we have computed the bending moment in x and y direction, so we have to compute the effective depth and area of steel. For the design of shear, Marcus suggested the expression of shear force. So the expression of shear force in shorter span, that is Wu into Lx by 3, and similarly shear force in longer span, that is Wu into Lx into r by r plus 2. So with the help of that we can compute the shear force in x and y direction, and once we have computed the shear force, so we can compute the nominal shear stress, and with the help of this nominal shear stress we have to check whether it is safe or not in shear with the help by comparing this nominal shear stress with the maximum shear strength of concrete. And after that we will check for the development length. So the check for the development length is exactly same what we have done in the previous class. So once we have computed the moment in x and y direction, compute effective depth d. So effective depth can be computed bending moment divided by q into b, and bending moment we have to take maximum bending moment. So effective depth can be computed as square root of 14 into 10 to the power 6 divided by q is, for Fe 415 grade of steel it is 0.138 FCK into 1000. So compute the value of effective depth. So the effective depth once we have computed, after that area of steel AST. So area of steel in x direction can be computed mu by 0.87 Fy d minus 0.42 xu, and xu can be replaced as 0.87 Fy AST divided by 0.36 FCK B. Similarly, area of steel in y direction can also be computed mu divided by 0.87 Fy into d minus 0.42 xu. Provide 10 mm bars and calculate calculate spacing. So everything is same. I have already done some problems related to this. So I will check for shear. That is different for previous discussion. So check for shear. So maximum shear force along longer direction. So VUY is equal to W into LX into R by R plus 2. So WU is 1.5 into total load is 12 into LX is 4.13 into R is 1.44 divided by 2 plus 1.44. So you can compute the shear force. Once you have computed the shear force, so nominal shear stress tau V is equal to VUY divided by B into D, and this value should be less than 0.5 times tau C max. Then it will be okay for the shear. Similarly, design for the development length can be, so last step is development length. So for the development length, LD you have to compute 0.87 Fy 5 by 4 into tau BD, and this development length should be less than 1.3 M1 by V plus L0. So you have to check this. So this is the procedure how to design the slab by Marcus method. So let us start another very important method, that is last method of slab design, that is IS code method. IS code method. So this IS code method, according to IS 456-2000, according to IS 456-2000, for restrained slab, code suggest D1.1 to D1.1.11 when the corners and edges are prevented from lifting. When corner and edges are prevented from lifting, that is restrained, that is called restrained slab. So according to clause T.1.1, moment of two-way slab, maximum moment for two-way slab can be computed as, so moment in x direction is alpha x into W into Lx squared, and moment in y direction is alpha y into W into Lx squared. So these are the moment computed for the restrained slab by IS code method, where alpha x and alpha y are the coefficient bending moment coefficient can be read from table 26 and table 27. So alpha x and alpha y are the coefficient can be read from the table 26 and table 27. So table 26 suggests bending moment coefficient for rectangular panel supported on 4 sides with provision for torsion corner, and table 27 bending moment coefficient for slabs spanning in 2 directions at right angles simply supported on 4 sides. So with the help of span ratio, various span ratio, the bending moment coefficient alpha x and alpha y suggested by the code for the 9 panels. And these 9 panels are, the first one is the interior panels, second one is the one shorter edge continuous, third panel is one longer edge discontinuous, fourth one is two adjacent edges discontinuous, fifth one is two shorter edges discontinuous, sixth one is two long edges discontinuous, seventh one is three edges discontinuous, eighth one is three edges discontinuous, and the last one is the four edges discontinuous. So with the help of that panel condition, we have to compute the alpha x and alpha y, and with the help of alpha x and alpha y, bending moment on a strip of unit length spanning Lx and Ly respectively can be computed. So where mx and fy, mx, my moments on strips of unit width spanning Lx and Ly respectively. Lx and Ly, length of shorter and longer span respectively, and alpha x and alpha y, as I told you earlier, that this is the coefficient given in the table 26 and 27. Code suggested that the values are given for alpha x and alpha y for 9 type of panels. These 9 types of panels are four, two, 3, and this one is 4, 2, 1, 3, 2, 4, 2, 4, and this is for the staircase 7th. Similarly, eight, 5, 6, 8, and the last one is 9. So these 9 panels are type of panels. The first panel, that is this one, these are the panels. So these panel are called interior panel. These are called interior panel. Second one is one shorter edge discontinuous. Second panel, this panel is one shorter edge discontinuous. Third panel is one longer edge discontinuous. Fourth panel is named as two adjacent edges discontinuous. Fifth panel is named as two shorter edge to shorter edge discontinuous. So in the question, any one type of the panel is given, and with the help of that panel you have to choose the bending moment coefficient in x and y direction. Sixth panel is named as two longer edges discontinuous. Seventh panel is named as three edge discontinuous. Means one longer edge continuous. Three edge discontinuous means one longer edge continuous. Eighth panel, three edges discontinuous means one shorter edge continuous. And the last panel is named as all four edges discontinuous. So code suggests, according to IS 456-2000 D 1.2. So code says that slabs are considered as divided in each direction into middle strips and edge strip. The middle strip being 3/4 of the width, and each edge strip 1/8 of the width. So if I draw division of slab into middle and edge strip, if this span is longer span Ly and this span is shorter span Lx. So code suggests that middle strip is 3/4. This is the middle strip, and the width of the middle strip is 3/4 times Ly, and this one is edge strip, and this one is also edge strip, and this edge strip, width of this edge strip is 1/8 of Ly. Similarly, so this is for span Lx. Similarly, for span Ly, code suggests this is Ly and this one is Lx. So this one is edge strip, this one is also edge strip, and this one is middle strip. So edge strip, code suggests the width of the edge strip is 3/4 times Lx, this one is, sorry, width of the middle strip is 3/4, 3/4 of the length, and edge strip is Lx/8 and Lx/8. So this is the division of slab into middle strip and edge strip. So this one is for span Ly. So what is edge strip and middle strip? So in edge strip, I will provide minimum reinforcement, and the larger diameters or main reinforcement is provided in the middle strip. So the direction of the reinforcement provided in this direction for span Ly, and for span Lx, reinforcement is provided in this direction, and the main reinforcement is provided in the middle strip, and the minimum reinforcement is provided in edge strip. So in the subsequent class, I will discuss detailing about the reinforcement, and after that provision of torsion reinforcement and problems related to the IS code method. So dear student, today I have discussed about the Marcus method. So I told you Marcus method is the modification over the Rankine-Grashof theory. So everything is same in the as Rankine-Grashof theory except a reduction coefficient suggested by the Marcus, that is 1 minus 5/6 r square by 1 plus r4. And another thing, new thing we have seen that for the design of shear, so Marcus suggested that design of shear in shorter and longer span, and the shorter span the shear force is Wu into Lx/3, and similarly in the longer span Wu into Lx into r/r+2. After that, I have discussed another method that is very important for the competitive examination point of view, that is IS code method. And IS code suggests the design of restraint slab, and for the design of restraint slab, IS code suggested the maximum bending moment in x and y direction, that is alpha x W into Lx square, and moment in y direction is alpha y into W into Lx square, when alpha x and alpha y is the bending moment coefficient that can be read by table 26 and 27, that depends on the condition. And code suggested this restraint slab is divided into 9 panels, and with the help of any one of the panel we have to read the value of alpha x and alpha y. After that, code suggests the width of the slab is designed for the in any direction for the middle strip and edge strip. So middle strip is 3/4 of that direction, length of that direction, and edge strip is 1/8 of the length of that any direction. So with the help of that, we as I told you that in the edge strip minimum area of steel is provided, and for the middle strip maximum or main reinforcement is main bars is provided. So in the subsequent class, I will discuss how to detailing of the reinforcement by IS code method, and the provision of torsion reinforcement by IS code method, and after that I will take some problems related to the IS code method. So take care of your health and happy learning.